Okay, here we have a histogram, and we're asked some questions about the distribution of these 1,000 people. And notice all that this is telling us is the ages of these people. The higher the bar tells us there's more people within that age range. So for example, let's just take a look at a specific bar. This bar right here would be 38 to 42. And there would be about 150 people in this population that are between 38 and 42. Okay, so they're first asking us where the mean is. So what we're really looking here is the center of the distribution, and you might say it's somewhere in here between 44 and 48. Seems to be about the cutoff point where you'd have the same number of people to the left and to the right. If we wanted to, we could actually estimate by saying, okay, how many people do we have here? Maybe 20 people here, maybe 60, that's 80 so far, 230. So somewhere in here we're going to hit the mean. The answer is 46, but notice that they would have taken this tolerance means that they would have taken between 44 and 48 as an answer. So just as an estimate, where's the center of the data here? And standard deviation, this one's a little trickier. So on a normal distribution, what we're looking for here is we want to go to the left and to the right of the mean by this value, by the standard deviation value. We want to capture about 2/3 of the data. So in a normally distributed data set, we're going to get about 2/3 of the data falling within one standard deviation to the left and to the right of the mean. And if I look at that, if I go out to here and maybe out to here, take half of these two bars, take both of these, I'm probably going to get between 600 and 700 people, which would be 2/3 of my 1,000. Again, this is an eyeball estimate, and here they would take between 4 and 8. So there was some flex room in what they're counting here. On part B, we're converting it to a relative frequency histogram. So notice that the shape is still going to be the same as with the standard histogram here. It's squashed down a little bit, but that really is just a matter of how much room we put on our axes here. That really has nothing of importance for us. But what does change is the values on the y-axis are changing. So instead of marking how many people, we're saying what proportion of the people, what percent of the people. And so in order to convert that, we can actually just look here. We notice that this 100 corresponds with this A. If we kind of look at where it's hitting on the bars, that's matching up with our 100. The 200 matches up with the B, and the 300 matches up with the C. So does that mean we put 100, 200, and 300 for A, B, and C? No, because we're looking at relative frequency. We want to know what proportion of the population. So if A stands for this 100, what is that 100 as a proportion? Well, it's 100 out of the 1,000 people. So 100 divided by 1,000 gives us 0.1, which is why A is 0.1. B would give us 200 out of the 1,000, or 0.2, and C would be 300 out of our 1,000 total, which would be 0.3. So that is how we convert it to the relative frequency histogram. And then what proportion of the people are age 50 or older? And whenever you see this about, you know that we're looking for some kind of visual estimate just to get a feel for the data. We don't have to do an actual calculation. So we're looking at 50 or older. Notice that this is the line for 50. So we're going across here. That looks like it's going to be about 0.15. Remember, the A is 0.1 and B is 0.2. So about 0.15 right there. Here we're going to come in a little under the A, so let's say maybe 0.8. So we'd have 0.15 or 0.08, sorry. 15% there, 8% there, that's 23%. and maybe another 5% there to give us 28%. Again, this tolerance is pretty large, so between 23 and 33% would have been accepted. The main point is that you realize you need to somehow calculate these 3 bars. Now, could you have instead used these 3 bars? Absolutely. So you could have found that this is 150 people, this is maybe about 80, maybe about 50 people right here. That would give you a total of 280 people. But then you would have to calculate the proportion, so we'd have 280 divided by 1,000 would give us 0.28. And they use the word proportion here, which typically is the decimal, but then they do put the percentage sign here, which is going to override that. So we do want to give our answer as a percent instead of a decimal. So 0.28 would convert to 28%. And again, keep in mind that there are some tolerance for these because these are just estimates.